Well, hi, and thanks for coming and joining me here in my shop this morning. This is a short 1-minute preface video I'm adding to the front of the real video to apologize for the continuous staticky sound you're going to hear all the way through the video you're going to watch. And it sounds exactly like radio static, but it's not. It was coming from my microphone. So unfortunately, that sound is there all the way through the video. So I apologize, and away we go. Well, hi, good morning. Thanks so much for joining me here in my shop this morning, where I'm going to be playing this radio hooked up to an antenna, and we're just going to find out how well this radio really works. In my earlier video, it appeared to be working fairly well, but I really didn't have it receive anything. So the interesting thing about this radio is, unless I'm mistaken, it's all original parts. So I just thought of something. There's one part hanging loose under this radio, and the other day when I went through the manual, there was a wiring diagram. You know what, I'm going to stop at this moment. That's how far I got into my plan, by the way, less than 1 minute before I diverged. I'm going to take a look at that wiring diagram and see where that big fat capacitor is really supposed to be connected. Okay, so it's C23 based on the size of the capacitor, and its location is right here. Here it is, C23. And even showing it physically larger than all the rest. They're just showing the standard size here. And look, it's connected to the chassis according to this. In fact, it's the back apron where they show it connected. So it's on the screen grid. It's a very large capacitor on the screen grid. Probably this is affecting the screen grid's number of tubes here. Let's just no, it's not really wise to operate this set without this capacitor in place, and I think it's just popped off. Again, as much as I hate to do this, I'm going to rearrange my bench. I spent quite a bit of time getting it set up here for this stuff. I got to turn the radio over. We got to sort this out. It is too big a capacitor to ignore. Yeah, I really did spend quite a bit of time just before I wreck everything. So here's the antenna sitting here, and I put new wires on it last night, so it's got nice new wires, and everything's set up here ready to go. And I am now going to tip the radio onto its back, onto its side. Oh my gosh. Let's flip it backwards here. Okay, so here's the capacitor I'm talking about, and it looks like it could make it to this. Almost. It's definitely on the screen grid. They show it onto the back apron here, but there's no solder at all. So what's just got me a little hesitant, and I can't imagine how this would be the case. Somebody has cut this on purpose. I can't imagine that's the case. Huh. Isn't that strange? How that would happen? How could that possibly happen? This capacitor is hanging out. Why don't we just give it a test? It's an important capacitor. It's trying to quiet the screen grid line. It's a 10 microfarad capacitor. Yeah, let's give it a test. 10 microfarad, I can test that on long test leads from my capacitor checker, no problem. So let's do that. Just gotta get a couple of things here. electrolytic capacitor like this, you would be smart to suspect it. So the test I'm going to do on this is a fairly simple test. I'm going to put a fairly high voltage on the capacitor and then measure or detect at least the amount of current leaking through the capacitor. This is an electrolytic capacitor, so I have to flip this to the electrolytic position. All electrolytic capacitors have a bit of a leak, certainly in comparison to your standard kind of capacitor. Electrolytics leak a lot. Okay, so the first test is going to be at 50 volts. That's a 450 volt rated capacitor, so it should be able to go fairly high. So we're watching the eye now to see if it closes and opens. See if it opens. It's going to close. Pop right open. Pop right open like crazy. Let's go up to 150. So it's only partly open now. And I'm sure at 250 it's just not going to open. But it's still open a little bit. Power factor control here, not making any difference at all. So what I'm going to do, I'm going to get a brand new 10 microfarad capacitor here. It's a little bit smaller than 16, 2. Yeah, a little smaller. And we're going to just repeat the test using the 10 here. Okay, do it with shorter units over here. This is more to calibrate my test machine and to calibrate me. I guess you too. Okay, 50 volts. Pop right open. 150. Right open. 250. Takes a little bit, but it gets right out there. So that's what a good capacitor would do. Now, the one we tested didn't do this. Now, a leak of that scale in a electrolytic capacitor like this is probably not of any consequence, really, but can't be sure. I mean, if the leak is sufficient, it's going to pull the screen voltage down, but by then you got other problems happening. Something like the last radio I worked on. So I'm going to put this in and we'll just connect it to the chassis. You know, here's a really good chassis thermal right here. So so funny, a little big guy out, a little tiny guy in. Yeah, I have options here for connecting this right in that spot. So I'm going to install this. Power's not on. I left a bit of a tail here on this wire. Okay, so I'm going to install this capacitor, then we'll get around to actually playing the radio. good capacitor in here now. All the rest, we don't really know. Solder doesn't seem to want to go on here. Oh, that's good. It's just me. Okay, I think we're ready to start them up now. Let's plug it in. Good. Antenna is plugged in, speakers plugged in, push buttons plugged in, and the 3 wires to the side plugged in, but I'm not sure they're plugged in correctly. Why don't we sort that out? So, one of these wires, one of the 3 wires that, oh, let me change cameras here. One of the 3 wires that comes up the side here is actually just going to the chassis. Right now that's in the center, so I'm going to take a look at the schematic here and just make sure that that's the way that should be. Okay, I studied the schematic. I had trouble with all these radios right at this point, figuring out how these 3 wires connect. And I see why, because on the schematic, in one place they're labeled A, B, C. Here they're labeled C, F, and R. They have other labels, but nowhere is it all kind of put together really properly. So C, F, and R, I have to guess that that's center, front, and rear. And that's the position of these. That's why I have to guess it. There's nowhere where it really says. So one thing's for sure, well, nothing's for sure here. The center one is ground, is connected to the chassis. So if we take the center one here, you can trace the wire and tell which one goes to the chassis. It's this one here. So I've got that in right. And then the wire from the back goes to the front. The wire from the front goes to the back. No wonder I've had trouble with this. Every one of these radios, I've gotten this wrong mostly. Okay, but no harm done. If you get these wrong, there's no serious. You're not going to burn anything up or anything like that. The radio's just not going to work right. Okay, I think we got it all right. I think we're ready to start now. Finally. Okay, so the switch is off. I'm going to switch it on. Volume is down. Band is band B. Band A. Want band A. Band A is the broadcast band. We're going to get a chance to see if the magic eye really works or not. Okay, we're ready here. So first we're going to apply controlled power, restricted power. There we go. Okay, we got a light coming on. It's good. The voltage at the radio is 110, falling a bit. Probably going to settle out around 100. Okay, there's nothing really going wrong, so I'm just going to maybe I'll just leave it on restriction for a few minutes here while we see if it works at all like this. The volume, not bad. Okay, now a really good piece of bad news is this is my outdoor antenna cable. This actually runs a long way through my house and eventually hooks up to a large outdoor loop antenna. And this is my shop connection here. There's nothing to it, just a clip lead I built. The last clip lead I built, I discovered last night, was open circuited. So The last radio project I did is I tried to connect to this antenna, and I was connecting with a cable that had an open circuit in it. Can you believe it? I can't believe it. I was so careful to make it, but obviously not careful enough. So this one is definitely working. There's quite a strong antenna signal on here. So we're going to put this on. Ground. That's full volume. I'm not putting the antenna on with full volume now. I'm going to clip it in the back here. Turn down. Okay, so I think the switch is off on the antenna. So I have to run and switch it on. So I'm going to leave this playing a little bit. I'm just going to run. It just take me a moment or so. Okay, so we can be pretty sure now there's a strong signal at the end of this antenna wire. Let's see what we can pick up. Ooh, not too good. Oh, huh.
Despite the tremendous progress we've made lowering our exposure to lead in society, we're looking at the water now and ways we can, make those levels even lower.
Well, let's talk about, and specifically Ontario schools. They're dealing with this backlog of repairs, $16 billion worth. So I would imagine
Not much happening with the eye.
Without all the lead pipes in your school, a lot of schools are, and you mentioned this off the top, they have to flush out their systems daily. What does that look like?
Well, I know
they're discussing lead in water. I won't get into lead in water. In my past, I was a corrosion technician, so I do have things to say about that. Here's what I would say. If you're concerned at all about metal in your drinking water in your house, then just don't walk up to the tap, stick the glass under it, and fill it up with water. Don't do that. Run the water for even 20-30 seconds. Get the water out of the faucet. Don't drink faucet water, and you should be fine. Maybe not if you live in Flint, though. Okay, let's go on full voltage here. Hey, how come I can't turn the volume rate out? Okay, a little more volume.
Lead pipes were used to bring
This is the tone control, Jim.
water mains into houses.
What's the school?
Something's going on because we have no volume control. We have apparently
Lead is coming from
two tone controls here. Which is which? Let me look on the cabinet.
copper plumbing nowadays.
Okay, so this is the volume.
Copper and copper pipes.
Yeah.
One of them, 1990, solder contains large levels of
We're talking about lead and solder. That's an issue here in the shop, isn't it? Okay. Let's tune. Now, this is kind of a... I think we're listening to 640. Let me just glance at the dial here. So 640... So with the pointer in the middle, that radio is tuned to about 900. 640 is over here. Oh, right. The pointer's not in the right place on the string. There we go. That's a little better. So we won't pick any AM stations up here. I'd be very surprised if we did. Even with my refangled antenna. The radio's performance seems very good, considering. So let's go hunt on shortwave. So this first band B is going to be all the way from 2 all the way up to 7, just above 7. So that's where we would be now, up around 7. Excuse me. It's possible to pick some stuff up at this time of day up here. Okay, crank the volume right up. So it's a little lacking in volume. Now we would expect to pick up funny stuff, even interferences from my house. There's some. Okay, next band. Band 31 meter band. This is 9 megahertz band. You should be able to hear stuff. Maybe this time of day. What time is it? It's 10 o'clock. Can't hear a thing. Okay, band switch security. Sounds like it's just receiving absolutely nothing. Let's get volume down to nothing. Still hear it. Next band. Some kind of tone in there. Hear that tone? You could hear it back here too quietly. Like a musical tone. It's quite distinct there. Something going on. Zero reception. It's a 25 meter band. 19 meter band. So 19 meter band is 15 megahertz. Yeah, 15 megahertz. We have a good chance of picking something up here. Maybe, maybe not. Separate off the antenna. Yeah, it's definitely receiving something. Okay, well that sort of suggests it's not working. That's what it suggests. But let's put in a controlled known signal rather than my antenna. And really let this radio have it, so to speak. What? When I did that AM, that's interesting. Let's just go back to the AM band for a minute. I kind of forgot about this gigantic loop antenna sitting here. Let's go back there. Okay, I'm going to take off this. Now we're relying on the loop antenna. 640 was around here somewhere. I think this is 590. Sports channel. Yeah, rotate the antenna here. That's all that scratchy sound. Gosh, the antenna's upside down. The sound's going to come out backwards here. So I can see the red glow in the eye, and I can also see the green glow a little bit. Let's check that.
He throws a pick against the Niners, he has a forced fumble against the Niners, and he ends up having a night where, he's got stuff 200 yards and 1 touchdown. Lamar Jackson wins next week against Houston. You're going to look at this very differently. Like, pick your horse out of the other 2 guys. That's all I would say. Yeah, Christian McCaffrey's going to have to be satisfied with rousing Ladaney and Tomlinson. It's the best fantasy season ever. Hey, I'm aboard the Air Canada fan flight to see the Leafs play in Florida in January. Listen to Air Canada's ideal sporting destinations for your chance to win your next ideal sport.
Very hard to see in the camera there.
List 5 of the destinations and listen for your cue to call this Friday for your chance to win. Find details at sportsnet.ca/590. When we come back, it's a text line Tuesday. Good show. Ben Addis, JD Buckus, Sportsnet 590 The Fan. For those teams still on the high of last year, we say, why bother coming down? For you, home of your NBA champion Toronto Raptors, Sportsnet 590 The Fan. Tune in after every Leafs game for Leafs Nation postgame, brought to you by your local GTA Acura retailer. Visit yours today. Sportsnet 590 The Fan.
Paul Coffey is one of the greatest scoring defensemen.
Okay, tuning the radio now.
Join Paul this
To the right lane. He's back in Milton, East Milton Snow Parkway. We had a crash in the left lane.
It's 403 is still busy from Winston Churchill to Severn Mills Parkway. Westbound side of the 401, that's jammed out from Morningside all the way through to west of Young Express and electric. And once again, Howard to west of Keel, making Express, and from your Ontario Collectors to Mavis. Southbound 400, just typical volume of the race tested. 27 major Mackenzie. And southbound 404, young riders southbound for
Push buttons. This is on push button setting now. No buttons are pushed. Sounds like it's doing something. Push the first button. Second button actually. First button turns on and off the phono input. Ooh, doesn't sound doesn't feel very good. Doesn't even stick. So the part of the mechanics here are stuck, so the buttons aren't even sticking properly. That one sticks, but I just hear absolutely no effect now. Maybe I got these wires wrong. Maybe those wires are wrong on the side still. And that's why we didn't hear anything on. No, these wires are only important when this is in push button mode for AM radio. Let's push the phono button here. There we go. So it cuts the sound off and energizes the phono. Connects to the phono thing. So we don't know what's going on here, something going on, or something not going on. Okay, so we're going to carry on with the signal generator. We're going to ram a signal in this radio and see if we can't get something to come out of the speaker on shortwave. Okay, so we're transmitting a signal out of my signal generator at 6742 megahertz. 6742 is... I'm looking for it on the dial here. Right at the end of the B. Right towards the end of the B. B band? Well, which end? This end. There he is. Kind of a classic radio sound there, eh? Okay. Good on that band. So we'll go to the next band. There's that sing-songy thing going on there. So this band now is the 31 meter band. So we'll dial up around 9 megahertz here. Might even hear it. There it is. So I'm feeding into the radio what would be considered a moderate signal. And it sounds pretty much like it should sound. Okay, let's keep going. Next band. 25. It's a dirty switch here. 25 meter band. 11.7. Okay, let's go up to 11.7. Down to it. So the pointer's there. That would be around 11.9. There it is. So the same signal level being sent to the radio, but now its reception is quite a bit weaker. Next band. There's that tone again. You can hear the same musical tone on every band. So now we're on 19 meters, just above 15. You can hear it there. So I would expect that level of signal from the signal generator to be a little stronger on the radio itself. And okay, so this last one is not really a band spread. It's 13 meter band, 16 meter band combined. This is between 17 and 22, so 18. So up at this end, it would be around 22. That's pretty high. Let's see what we get here. 22. 22 what? 22, well, 22, exactly 22. Somewhere in here. I'm going to turn the signal generator up a notch. Okay, can we find it now? There it is, very weak. So I boosted the signal by a factor of 10, and you can see the response is actually way down. Now we're at the limit of this radio. We're at the high end of the highest band. This is the highest frequency stuff this radio has to deal with. There's still something coming through. Okay. Great. No, that's really something. So this is all original except for that one capacitor I just put in. Unfortunately, we don't know how the radio was operating before I made that change. But I think it's kind of crazy to operate this radio without a big capacitor on the screen grid. So, great. I think the next stage of this radio, just noticing that the eye is so weak, probably indicates other tubes are weak too. Kind of reach that sort of notion. So I think it's tube testing time for all the tubes in the radio. But I'm not sure whether I'll extend this video or not. Depends how long it is at this point. So maybe I'm saying farewell for today, and tomorrow we'll carry on. In the meantime, you know what I'll do? I'll test the tubes during the day on my own. I'm like puttering around the house, and then tomorrow we will start with a radio full of good tubes and go from there. Thanks a lot for watching, and enjoy your day.